Elimination भन्ने बित्तिकै सबै सकिहाल्छ. Okay. So let's start about the elimination. When you say elimination reaction, the word itself gives you the meaning. What does eliminate means? Eliminates means something is going out, is removed. So with the contents of this reaction, हामी के छ organic reaction पढ्दैछौँ, reaction mechanism पढ्दैछौँ, organic chemistry पढ्दैछौँ भन्दाखेरि with this reference, how to define elimination reaction? Eliminate, something is going out, remove. अब यहाँ के गइरहेछ त के हुन्छ त elimination reaction भन्ने बित्तिकै भन्दाखेरि you can simply, this elimination reaction you have studied in your school as well as in your previous classes. तर त्यसैलाई recall गर्दाखेरि action which involves the removal of atoms or groups of atoms from two adjacent carbon atoms in the substrate molecule to form the multiple bond. So what is elimination? Reference to the organic chemistry bandakeri. Yes, in this case, organic chemistry, carbon must be there. Tara, यहाँ के भनिरहेछ भन्दाखेरि with the syllabus को तपाईको जुन elimination reaction मा पनि फेरि if you go to elimination reaction, there are different type of elimination as alpha elimination, beta elimination भन्ने छ, gamma छ. तर यो केस भनेको beta elimination type को छ र यसमा के a type of chemical reaction which involve the removal of atoms or groups of atoms from two adjacent carbon atoms. यो पनि याद गर्नु होला है. तिम्रो reaction mechanism लाई के छ? That is beta elimination, that is from two adjacent carbon atoms in the substrate molecule to form the multiple bonds, so that the single bond will change into double, or even the double may change into triple. तर हामी single bond to double bond लाई मात्रै त्यो गर्छौं. Okay, and here we can take a good example of dehydrohalogenation, or यसलाई चाहिँ नि लामो sentence मा लेख्दाखेरि we can take a good example of the hydrolysis or reaction of the primary alkyl halide with heated alkali in an alcoholic medium. यसैले लामो लेख्न मिल्छ, तर मैले यहाँ सजिलोलाई के छ dehydrohalogenation. जब dehydrohalogenation भन्ने बित्तिकै you know the meaning of D, that means removal. के remove भइरहेको छ त भन्दाखेरि hydrogen and halogen is going out at the same time. So it is known as dehydrohalogenation. र यो dehydrohalogenation कस्तो reaction मा हुन्छ अथवा कुन condition मा भन्दाखेरि a good example is the primary alkyl halide, and in the case of the primary alkyl halide you cannot take the example of the halomethane. Halomethane यहाँ लिन मिलेन as in case of SN2. SN2 मा हामीले dehydrohalogenation of primary alkyl halide भनेर bromomethane लिएर के छ substitution reaction गर्यो, bromomethane ले methanol दिएको थियो in the SN2. तर यो केसमा हामीले bromomethane लिन मिल्दैन, के भनेछ group of atoms are removed from the two adjacent carbon atoms of the substrate. है यो याद गर्नु होला. धेरैले बुझेकोले त याद गरिहाल्छ, तर कुनै कुनै नबुझेको मेबी क्लासमा एब्सेन्ट भएको कसै छ के छ भन्दाखेरि ब्लन्डर के गर्छ भन्दाखेरि यहाँ ब्रोमोमिथेन लेखिदिन्छ, यहाँ इथेन लेखिदिन्छ है. जान्सको कपीमा त्यस्तो पनि आउँछ, तर बुझेकोले कहिले पनि गर्दैन. So this is a this is a halo alkane beside the methane, and here is NaOH or the QH in an alcoholic medium, and generally the heat is required here in the case of elimination reaction and from the corresponding alkene with the formation of water molecule and the corresponding sodium or the potassium halide or whatever the removal group is there. And the mechanism of the elimination reaction is explained by E1 and E2 reaction mechanism. Okay, again, simply what is elimination reaction? तपाईले स्कुलमा पढिसकेको छ, याद गर्नु होला. Dehydrohalogenation. Dehydrohalogenation भन्ने बित्तिकै that is with the primary alkyl halide with NaOH and QH in an alcoholic medium, and it must be heated. अब यसमा it is said that the mechanism is explained by E1 and E2. जस्तै चाहिँ नि substitution reaction के थियो? Substitution reaction पनि it was explained by SN1 and SN2. त्यस्तै गरेर explained by E1 and E2 mechanism, right? So what does E2 represent then? E2 भन्नाले के बुझिन्छ त भन्दाखेरि This E2 represents the bimolecular elimination reaction. Example, represent bimolecular elimination reaction. And for this example, dehydrohalogenation of primary alkyl halide in alcoholic medium. Dehydrohalogenation of primary alkyl halide मात्र भन्ने बित्तिकै पनि बुझिन्छ, किन भन्दाखेरि dehydrohalogenation भनेको alcoholic medium मात्र हुन्छ, स्पेसिफाई गरे पनि पर्यो भयो, अथवा यो dehydrohalogenation नलेखँदा you can write, or when the primary alkyl halide is heated with alkali in alcoholic medium. So this is the alkyl halide, primary alkyl halide with the NOH or the QOH. When it is heated, gives its corresponding alkene. And here, if you take the bromopropane as a primary alkyl halide, then you get the propene. If you take the bromoethane, then ethene. But by taking the methane, you cannot give the methane. त्यो चाहिँ नि याद गर्नु होला, जाँचको कपीमा अब नआओस् है. So this, when you say E2 represents the bimolecular elimination reaction, that is the good example is when the primary alkyl halide is heated with alkali in alcoholic medium. र यसरी जुन छ elimination reaction मा के भइरहेको छ भन्दाखेरि hydrogen and halogen is going out, right? Hydrogen and halogen is removed. So as the hydrogen and halogen is removed, we can also say in this elimination reaction, the two sigma bonds are broken and one new pi bond is formed. हैन त, यो what is sigma bond, what is pi bond त तपाईले पर्यो होला. यहाँ जुन छ, they are the sigma bonds here. Okay, एउटा hydrogen and here the Br is removed. That means the two sigma bonds, at least the two sigma bonds are broken and at least the one new pi bond is formed in the elimination reaction. If यदि यहाँ चाहिँ अझ double bond बाट triple bond मा जानु छ भन्दाखेरि के छ, then again the one at least भनिरहेछ हैन, the two that is the pi bond is formed. तर यसमा हामी single bond to double bond मा मात्र confirm गर्छौं, confine गरेर पढ्छौं. So bromopropane give you propene, अथवा bromoethane, अथवा अथवा chloroethane or iodoethane give you the ethene. So this is about E2. So E2 explained by E2, and this represent by with alkali in alcohol, it represent alkene is obtained by dehydrogen. This like E2 like what does it represent? Okay, here is a bromopropane, and it is said that here the rate of the reaction depends upon the concentration of the substrate and the base. So it is second order reaction, so that you can write here directly proportional or equal to एउटा चाहिँ नि के छ constant दिन पर्यो, and then that is to the concentration of the substrate and the base. Therefore it is second order reaction. है, अब यसमा के छ, E2 मा bimolecular पनि भइरहेछ second order, as in the case of SN2. SN2 मा पनि हामीले bimolecular र second order भनिरहेको थियो, यसमा पनि bimolecular र second order. तर यो केसमा हामीले rate of the reaction मा instead base it's okay, that instead of nucleophile in the as in case of SN2 मा हामीले यहाँ के छ base nucleophile लेखेको थियौं भन्दाखेरि, but now it is better to write the base for the same hydroxide ion. यहाँ पनि hydroxide ion नै हो, तर यो केसमा nucleophile भन्नु भन्दा base is better. किन त भन्दाखेरि हामी mechanism मा जान्छौं है त. This mechanism is very simple. Okay, mechanism of E2 is very simple and it is one sentence. So if you're asked to explain the SN2 reaction mechanism, then it goes that SN2 reaction mechanism occur in the hydrolysis in the your sentence lekhnu hola, occur in the hydrolysis of the primary alkyl halide, when primary alkyl halide is heated with the alcoholic or with the alcoholic alkali, may be the NOH or the QOH, okay, and give its corresponding alkene, and it is explained in just one step. That is the dehydrate. This is here, bromomethane is give this. अब यो mechanism मा के छ, just one sentence is here, very simple. र यो one sentence ले नि explain गर्न सक्ने भएकोले यदि जाँचमा आयो भन्दाखेरि अब यसलाई चाहिँ नि लेख्ने देरी छैन, त्यसैले मार्क्स पनि देरी आउँदैन है। फुल मार्क्स यदि यसको चाहिँ नि एक्सप्लेन द E2 रिएक्सन मेकानिजम भन्दाखेरि जस्ट 2 मार्क्सको लागि मात्रै आउँछ। 2 मार्क्स फर यो जुन छ रिएक्सन देखाए एउटा चाहिँ स्टेटमेन्ट। अब स्टेटमेन्ट जुन छ E2 मेकानिजमले के भन्छ, इन E2 मेकानिजम द बेस, ओके, द बेस दैट इज द हाइड्रोक्साइड आयन, यहाँ जुन छ सोडियम हाइड्रोक्साइड KOH जुन छ आयनाइजन भएर जुन हाइड्रोक्साइड आयन दिन्छ, this base it abstracts the proton from the beta carbon of the primary alkyl halide and simultaneously the halide leave and forms its corresponding alkane. Okay, यो स्टेटमेन्ट बुझ्नलाई यहाँ हेरौँ त, हामीले चाहिँ कुनै पनि यो प्राइमरी अल्काइल हालाइड यसरी लेखेको छ भने यहाँ के बुझिन्छ त भन्दाखेरि यो आयनाइजेसन भएर जुन हाइड्रोक्साइड आयन बन्छ, that hydroxide it abstract the proton from the beta carbon. अब यो जुन छ अल्फा र बीटा भनेर you know होला, अल्फा भन्ने बित्तिकै the one which have the halide or the function group that will be alpha carbon, then the beta or the gamma, यसरी चाहिँ कार्बनलाई पनि यसरी क्लासिफाइड गरिन्छ अल्फा बीटा है। so this is a beta carbon भन्दाखेरि के गरेछ भन्दाखेरि this hydroxide it abstract the proton भन्दाखेरि यहाँ bonded pair of electron छोडेर जान्छ, okay, it leaves. So this bonded pair of electron will move to form the double bond between this alpha carbon and the beta carbon. And as this bonded pair of electrons is shifted to form the double bond between this and this, then the leaving group, that is the halide, it leaves along with the bonded pair of electron. It leaves with the bonded pair of electron, and this will again combine with the sodium and form the sodium hydroxide or the potassium hydroxide, potassium halide, whatever the X is given here. अब यसलाई एउटा यस मैले अर्को चाहिँ लेखेन, यसलाई एउटा अर्को स्टेपमा लेखे पनि हुन्छ, यहाँ कि H राखे पनि भयो. If it is H and this is Br, then you'll get the ethene, H is here, ethene, H2O, and the NABR. If here CH3, then it will be a propene, H, ethene. Okay, now here the hydroxide is said to be the base instead of nucleophile. Why? किन यसलाई हाइड्रोक्साइडलाई बेस भन्नु भन्दाखेरि, of course तपाईले यो भन्दा प्रिभियसमा you have defined the acid and the base with different concept, है. Arrhenius concept of acid and base पढ्नु भयो होला, त्यसै गरेर Levy's concept of acid and base पढ्नु भयो होला, त्यसै गरेर Lowry and Bronsted concept of acid and base है पढिसक्नु भयो होला. So यो केसमा as this hydroxide abstract the proton is said to be the base भन्दाखेरि the one which give the proton is the acid, which accept the proton is the base भन्दाखेरि कुन बेसमा भयो, which concept is it the Levy's concept, or is it the Arrhenius concept, or is it the Lowry and Bronsted concept? यो कुन concept अनुसार चाहिँ नि हामीले यो जुन hydroxide छ, this hydroxide is said to be the base भन्दाखेरि I think it is the Lowry and Bronsted concept. Right? So this concept like is the base, the acid is the one which donate a proton is the acid, and which accept the proton is the base. So with that concept, this hydroxide is said to be the base instead of nucleophile. है हामीले SN2 मा nucleophile भनेको थियो किन भन्दाखेरि यो जुन bonded pair of electron ले के छ यसले directly substrate carbon सँग bond बनाउँछ. Okay, first partial bond and complete bond बनाउँछ, त्यसैले यसलाई nucleophile भन्यो in the case of SN2, SN1, तर यसमा elimination मा better to say as the base. So in E2 mechanism, the base, that is hydroxide, abstract the proton from the beta carbon of the primary alkyl halide, and simultaneously the halide leave and form its corresponding alkane भन्दाखेरि just one step है. अब यसमा के छ भन्दाखेरि जुन middle step छ, ओके त्यो मिडल स्टेपलाई चाहिँ नि मैले यहाँ ओमिट गरिदिएको छ किन भन्दाखेरि मोस्ट अफ द बुक्समा यो चाहिँ नि मिडल स्टेप चाहिँ नि देखाइरहेको छैन तर कुनै कुनै राइटर्सले अहिले आएर राइटर्सहरूले के गरे भन्दाखेरि SN2 मा जस्तै के गर्नु खोज्यो भन्दाखेरि दिस एज इट एब्स्ट्र्याक्ट द प्रोटोन यहाँ बन्ड ब्रेकेज हुन थाल्छ र यो मिडल स्टेपमा यहाँ बन्ड ब्रेकेजलाई यहाँ डटेड लाइन राखिन्छ त्यसले यहाँ फर्मेसन अफ द कार्बन कार्बन डबल बन्डलाई यहाँ डटेड लाइन राखेर अनि फेरि ब्रेकेज अफ दिस लाइन चाहिँ डटेड लाइन राखेर देखाइरहेको हुन्छ कुनै कुनै यो नयाँ राइटर्स नेपाली राइटर्स अथवा यो न्यू राइटर्स तर इट इज नट सो नेसेसरी नभएकोले मैले चाहिँ लेखेको छैन है त्यसैले दिस इज जस्ट अ वान सेन्टेन्स र मार्क्स पनि धेरै आउँदैन इफ यु आर आस्क्ड टु एक्सप्लेन द E2 मेकानिजम त्यसको फुल मार्क्स भनेको 2 भन्दा बढी मार्क्सले आउँदैन बिकज इट इज जस्ट वान सेन्टेन्स तर बुझ्नु पर्यो okay यो कसरी हुन्छ so for that I have taken this as an example for you for interesting case if you are interested with the formation of ethene then you instead of R write the H so that you get the ethene if you need the propene then the you write the CH3 or high alkene cha bandakeri you can write here C3H7 or C4 H9 so the upon the corresponding alkene kun boni to leave. So this is about the E2 mechanism. So this E2 mechanism is very simple. अब यसमा कुनै transition step अथवा यो intermediate step भनेर पनि बुझाइराख्नु पर्दैन र यसमा के अर्को point भनेको यसको geometry. यसमा geometry पनि के छ कुनै चाहिँ नि difference नभएको होला geometry पनि त्यसलाई चाहिँ नि mention गरिराख्न पर्दैन. Right? So very simple than your SN2 mechanism. So this is your E2. Now let's go to E1 as an elimination. You saki also kin banda ke very simple. SN1 SN2 banda you E1 E2 sign simple bakale you saki also. Tesai garera what does E1 represent then? Right. In the case of E1 reaction, it represents the unimolecular elimination reaction, as in SN1, unimolecular. Example is when tertiary alkyl halide is heated with alkali in alcoholic medium, its corresponding alkene is obtained. Or an example of dehydrohalogenation of tertiary alkyl halide. जहाँसमा लेख्दाखेरि अलि डिहाइड्रोलाइजेसन भन्दाखेरि पनि यदि काम टाइम छ त्यसो भने अलि लामै लेखे पनि राम्रो हुन्छ okay it depends upon you okay so that is a good example is the that is when tertiary alkyl halide is heated with the alkali in alcoholic medium and for the tertiary alkyl halide now you can take the tertiary butyl bromide or the 2-bromo-2 methyl propane for the tertiary alkyl halide which we have also taken this example in the SN1 reaction mechanism. Hey, SN1 reaction mechanism पनि हामीले के भनेको थियो example SN1 को लागि dehydrohalogenation of the tertiary alkyl halide so that it give tertiary alcohol. त्यहाँ के छ substitution SN1 substitution Br को ठाउँमा के छ that is the nucleophile बस्छ र you get the corresponding alcohol but elimination is here. So elimination हुँदाखेरि यहाँ के छ भन्दाखेरि yes the tertiary alkyl halide लाई हामीले त्यही लिन मिल्यो तर यहाँ के छ त here the one of the hydrogen from the beta carbon now यसमा कतिवटा beta carbon छ भन्ने हेर्दाखेरि now यहाँ के छ this is the alpha beta beta and beta तीनटा यो carbon is the beta yeah एउटै मात्र beta तीनटै carbon is of similar that is beta र अब के छ भन्दाखेरि यसलाई बिटा कार्बन मानेर तपाईले जुन छ सरी यतालाई बिटा कार्बन मानेर तपाईलाई जुन छ यो प्रोटोन हट्यो भन्दाखेरि you get the 2-methyl propene अथवा यसबाट प्रोटोन हटे पनि you get the 2-methyl propene and यसबाट गए पनि you get the 2-methyl propene. And this it is said that the rate of the reaction here depends upon the concentration of the substrate only. So it is first order reaction and here it is first order reaction similar to SN1. SN1 मा पनि के भइरहेको थियो unimolecular first order. SN2 bimolecular second order. तपाईलाई सम्झिनलाई पनि सजिलो हाम्रो कोर्स डिटेनिङमा पनि हामीलाई यो एक्जाम्पललाई दिएको छ. So we have taken this example. Okay, so what does E1 represent for your 1 marks? Then represent this example and then the kinetics kita. Right. So after that, then explain its mechanism. Okay, explain the E1 reaction mechanism भन्ने बित्तिकै now. Similar to the SN1, this reaction mechanism is also explained in 2 steps. Okay, when you say E1 reaction mechanism, yes, it occurs in the dehydrogenation of the tertiary alkyl halide in alcoholic medium, or when the tertiary alkyl halide is heated with the alcoholic NaOH or the KOH alkali, then you get the alkene. Dehydrogenation word okay, statement depen boy. The mechanism is explained in 2 steps. It is said that the first step, sir, this first step is very similar to SN1. हामीले जुन हिजो कहिले पढेको तिमीहरूको क्लास सन्डे okay जुन SN1 मा पनि हामीले के भनेको थियो, first step is the formation of the intermediate, that is the tertiary carbonium ion. Tertiary alkyl halide, tertiary carbonium ion is formed. कसरी त? By ionization. The tertiary alkyl halide see, the tertiary alkyl halide ionize slowly to form the tertiary carbonium ion as an intermediate, and the leaving group leave the substrate with the bonded pair of electron, so possess negative charge. Okay, it ionize and form the tertiary carbonium ion as an intermediate, and then the halide leave along with the bonded pair of electron. Now, this tertiary alkyl halide okay, this tertiary alkyl halide ma ke cha भन्दाखेरि tertiary alkyl halide ma now in this case हामीले orientation को पनि कुरा गरिराख्नु पर्दैन. एकचोटी बन्ने बित्तिकै tertiary carbonium ion बन्ने बित्तिकै के छ, the base will immediately abstract the proton one at the time. एउटा tertiary carbonium ion बाट it abstract the proton. The base abstract the proton from the beta carbon and forms the corresponding alkene. And here is your 2-methyl propene. Your tertiary carbon ion बन्ने बित्तिकै the reaction is very fast. Okay, here the base abstract the proton. अब तपाईलाई proton कताबाट abstract गर्नु छ, त्यसलाई bond यसरी breakage गरेर देखाउनु होला. यो पनि बीटा कार्बन हो, यो पनि बीटा कार्बन, this पनि बीटा कार्बन बनेकोले यताबाट यदि abstract गर्नु छ भने एकै पहिला चाहिँ यो देखायो भने देखाउनलाई यसरी सजिलो हुन्छ. This base will abstract this proton र bonded pair of electron यसरी shift हुन्छ and then form the 2-methyl propene with this double bond here. तर यदि तपाईले यताबाट प्रोटोन abstract गर्नु छ भन्दाखेरि पहिला यहाँ CH2 र bondलाई with bonded with the hydrogen atom देखाइदिनु होला, so that this base will abstract the proton and then form the here the double bond is formed. यहाँ double bond form भयो पनि 2-methyl propene. यदि यता देखाउनु छ भन्दाखेरि पनि यहाँ CH2 and the H, so that you can abstract the proton from here by the base and the double bond is formed. Each यताबाट remove गरे पनि यताबाट remove गरे पनि यता remove गरे पनि you get the 2-methyl propene. And this reaction is very fast. र यही reaction हामीले SN1 मा भने जस्तै this is slow, this is fast, as this is slow, the rate of the reaction here depends. The slowest step will determine the rate of the reaction. So this so the rate of the reaction depends only on the concentration of this, that is the tertiary butyl bromide. So it is first order reaction. And the formation of the intermediate involves only the tertiary carbonium ion. So it is unimolecular. So very easy to remember. So this is your E1. When you say E1 mechanism, that is the dehydrogenation of tertiary alkyl halide. Jun tertiary alkyl halide तपाईले जुन SN1 मा जुन use गरेको त्यहीलाई example लिएर first step is same as SN1, but of course naming is different. SN1 substitution या elimination भन्दाखेरि here then the base abstract the proton and form the corresponding alkene. अब तपाईलाई एउटा अर्को के हुन सक्छ भन्दाखेरि when this is asked के हुन सक्छ भन्दाखेरि yes explain the dehydrohalogenation of the tertiary alkyl halide भनेर explain the mechanism of the dehydrohalogenation of tertiary alkyl halide भनेर क्वेशन दिएको छ भने तपाईले के बुझ्नु पर्यो ए dehydrohalogenation of tertiary alkyl halide भन्ने बित्तिकै E1 mechanism then go on writing तर मैले फेरि भन्छु जाँचको कपीमा यस्तो क्वेशन पनि आएको छ र जाँचको कपीमा के आएको छ भन्दाखेरि dehydrohalogenation of tertiary alkyl halide तर SN1 reaction mechanism लेखेको छ अब SN1 reaction mechanism लेखेपछि त 0 मात्रै पाउँछ र किन लेख्यो होला एनालाइज गर्दाखेरि के बुझिन्छ अब यो जुन छ dehydrohalogenation को यदि बोध त्यसले बुझेको छैन भने नि एक्जामिनीले त्यसैले लेख्यो होला किनभने the word itself dehydrohalogenation भन्दाखेरि हाइड्रोजन हालोजन is going out भनेपछि त्यो SN1 कसरी लेख्यो होला we don't know के त्यति बेला फेरि एक्जामिनेसन को टेन्सन हो कि we don't know त्यसैले मैले भनिहाले के छ भन्दाखेरि बिफोर राइटिङ या आन्सर पहिला माइन्ड मेकअपमा ए यो क्वेशनले के खोजेको छ बी कन्फिडेन्ट एन्ड देन गो राइटिङ है सायद त्यसलाई यो पनि आएको थियो होला के भएर चाहिँ कन्फ्युज भएर त्यो लेख्यो वी डोन्ट नो सो बिफोर राइटिङ इफ यु आर आस्क्ड एक्सप्लेन द E1 रिएक्सन मेकानिजम भनिरहेको छ SN1 अब मेबी अब त्यसले चाहिँ E1 नपरेकोले आफूलाई जुन आउँछ ए मलाई SN आउँछ त्यही लेखौँ भनेर लेखेको पनि हुन सक्छ एनालाइसिस पोइन्ट गर्दाखेरि हामीले के छ त्यसरी पनि एनालाइज आएको थिएन होला अब टाइम पास लेख्यो होला टाइम पास मात्र गर्यो इट्स 0 सो these about the SN1 and the SN1 SN2 we have done so this is very simple today this is E1 and E2 E2 is here and then the E1 is here है अब यति परिसकेपछि नाउ यस अर्को सेट्सेफ रुल भनेको दिस यो एलिमिनेसन रिएक्सन सँग अलिकति रिलेटेड
क्वेशन छ का एउटा बेसिक क्वेशन
भन्नुस् ल भन्नुस्
यो जुन E1 मा स्टेप 2 मा जुन कार्बोनियम आयन सँग बेस OH इन्टरेक्ट गर्छ नि त्यसरी जस्तो एउटा बेसिक क्वेशन है त OH ग्रुपले यो कार्बन के रे यो OH बेसले चाहिँ कार्बोनियम सँग इन्टरेक्ट गर्दा अल्कोहल चाहिँ किन नबनाएको होला किन अब यो प्रोपिनै अल्किनै बनायो त
यो अल्कोहलिक मिडियममा गर्दाखेरि त्यो अल्किनै बन्छ के अल्किनै बन्छ त्यसमा अल्कोहलै त्यो बन्दैन यो किन भन्दाखेरि अल्कोहलिक मिडियम त अलरेडी इज देयर हैन अल्कोहलिक मिडियममा गर्दाको छ नि त त्यसैले यहाँ चाहिँ इलिमिनेसन नै हुन्छ जहाँ चाहिँ नि यस्तै रिएक्सन हाइड्रोलाइसिसमा हामीले अक्युज मिडियम भनिरहेछ त्यहाँ चाहिँ नि के छ सब्स्टिट्युसन नै हुन्छ यदि दुईटाको चाहिँ नि कम्पेयर गर्दाखेरि यो अल्कोहलिक मिडियम र अक्युज मिडियम राखेर सेम ओके दैट इज हाइड्रोलाइसिस भन्दाखेरि हामीले यो पनि लिएर गर्यौं त्यो पनि गर्यो तर मिडियम डिफरेन्ट हुन बित्तिकै के रहेछ अल्कोहलिक मिडियम विल फेभर्स द एलिमिनेसन रिएक्सन whereas the aqueous medium will favors the SN2 reaction mechanism त्यो पनि पोइन्ट हो है
ए हुन्छ म्याम ओके
अब आइसकेपछि अब एलिमिनेसन रिएक्सन पछि फेरि यो एउटा पोइन्ट छ के 11:05 सम्म ओके यो सेट्सेफ रुल भनेर सायद नेमिङ रिएक्सनमा तपाईले पहिला पढिसकेछ याद छ
यस म्याम पढेको म्याम
ओ यस भेरी गुड तर के पढे कसो भयो बिर्सिन सक्छ लेट्स रिमाइन्ड अब सेट्सेफ रुल भनेर तपाईले पढ्यो होला तर सेट्सेफ रुल भन्दाखेरि हामी एलिमिनेसन रिएक्सन पढिरहेकोले पहिला यतातिर जाउँ है एक्जाम्पल अब if we take an elimination reaction which contains the two beta carbon different beta carbon यो जुन छ this is your alpha भयो that is 2 bromobutane मा हैन र भन्दाखेरि नजिक is this या beta carbon and this is also beta carbon अघिको हामीले चाहिँ नि के टर्टियरी ब्युटाइल ब्रोमाइडमा के त्यो बिटा कार्बन सरी यसमा के देख्यो भन्दाखेरि बिटा कार्बन यताबाट जताबाट निकाले पनि यु गेट द 2 मिथाइल प्रोपिन तर यो केसमा के रहेछ त if reaction take place and if this base abstract this proton from here then the bonded pair of electron move here, then it goes out and double bond is formed here. That is your this 1-butene. At the same time, if the base abstract this proton, okay, bonded pair of electron is shifted here, and this goes out, and the double bond is formed here. That is here. That is your 2-butene. So if the elimination reaction, so what happens when the elimination reaction is done with 2-bromobutane, or if the elimination reaction gives 2 types of alkene, then which alkene is formed in greater amount, or are they formed in equal amount? And this answer is given by Zaitsev rule. Zaitsev rule ke bhन्छ, if the elimination reaction forms different type of alkene, then the highly substituted alkene is formed in higher amount. A greater amount is formed, that is the highly substituted alkene. In dihydrolyl alkyl halide can yield more than 1 alkene, then according to Zaitsev rule, the main product is the most highly substituted alkene. खाली तपाईले बुझ्नु पर्ने के रहेछ, the main product भनेको धेरै कुन बन्छ त is the most highly substituted alkene. र highly substituted alkene यहाँ कुन हो त, 1-butene मा हो कि 2-butene मा भन्दाखेरि, of course highly substituted alkene भन्दाखेरि जहाँ चाहिँ नि highly substituted alkene भन्दाखेरि alkene मा R group, alkyl group कुनमा बढी छ त हैन त, यहाँ एउटा मात्रै छ 1-butene मा, एउटा R, that is your C2H5, तर 2-butene मा दुईटा alkyl group, एउटा CH3 and एउटा CH3. यहाँ R दुईटा छ alkyl group, तर यसमा एउटा मात्रै छ भन्दाखेरि Zaitsev rule के भन्यो, the main product is the most highly substituted alkene भन्दाखेरि, so this 2-butene is formed in greater amount than the 1-butene. सबैमा यो बाहेक अरु पनि elimination reaction मा यसरी if give two different type of alkene, then highly substituted alkene is given. यो केसमा मात्र के भनिरहेछ भन्दाखेरि 2-butene is formed in 80% and 1-butene 20%. पुरानो किताबमा नयाँ edition मा 81 and the 19%. So this is about the Zaitsev rule that is related with the elimination reaction. त्यसले 1 marks लाई what is Zaitsev rule? हुन Zaitsev rule भनेको सोध्न मिल्दैन, this is name reaction हो, तर यदि elimination reaction सँग content सँग question सोध्ने हो भन्दाखेरि it must be asked that if the elimination reaction give more than 1 alkene, then which alkene is formed in greater amount? Show your answer with a suitable example. Right? If this elimination give more than 1 alkene, then you can take a good example of 2-bromobutane here, which possess this beta and this beta. If the proton is abstracted from here, 1-butene is given. If the proton is abstract from this beta, then you get the 2-butene. And according to then Zaitsev rule, the main product is the disubstituted alkene, that is 2-butene, rather than the monosubstituted alkene, that is 1-butene. What is Zaitsev rule भनेर 1 marks लाई पनि आउन सक्छ है. अब यति गरिसकेपछि of course factors governing E1 and E2, हामीले factors governing SN1 and SN2 जस्तै त्यही conceptमा we can write how the nature of the nucleophile governs or favors E1 and E2, how the nature of the solvent favors E1, E2, how the nature of the substrate govern E1, E2, or how the nature of the leaving group govern E1 and E2, 1 marks, or how I'll write the factors that govern E2 and E1 for your 3 to 4 marks. So with the same concept of the SN1, SN2, हामीले त्यही pattern बाट we can ask that, we can write that nature of the nucleophile here, the concentrated and the strong base favors E2 reaction mechanism because the rate of E2 depends upon the concentration of the base, जुन हामीले पहिला भन्यो, okay, and it abstract the proton from the carbon directly as abstract गर्ने भएकोले, the stronger the base, okay, stronger the base favors E2, concentrated base favors E2, किनभने rate depend गर्छ. तर even the low concentrated and even weaker base favors the E1 reaction because the rate of E1 reaction does not depend upon the concentration of the base and does not directly abstract the proton from the substrate. Likewise, यही यसै प्याटर्नले हामीले SN1 SN2 लाई पनि यसरी नै एक्सप्लेन गरेको थियो नेचर अफ द न्यूक्लियोफाइड. त्यसैले राम्रोसँग यदि मेकानिजम बुझेको छ भन्दाखेरि you can write this in your own words. Likewise, nature of the nucleophile. Okay, highly polar solvent favors E1 reaction. Kino ta? Because it proceeds by ionization. Jahan ionization huncha, polar solvent favors. And even the non-polar solvent favors the E2 reaction mechanism because it does not occur by ionization. Right? The principle ho. त्यसै गरेर nature of the substrate. Nature of the substrate ma dehydrohalogenation of the primary alkyl halide favors E2 reaction mechanism. Whereas the but the dehydrohalogenation of the tertiary alkyl halide favors E1 reaction. This way, dehydrohalation of the secondary alkyl halide can occur by E2 or E1. Kinman or mechanism is E1, E2, E3 China. Key E2, key E1. So in presence of the strong and the concentrated base. Okay, so in presence of strong and concentrated base and in non-polar solvent, that the secondary alkyl halide, it occurs by E2 mechanism, but in weak and low concentrated base and in polar solvent, it occurs by E1 reaction mechanism. त्यसैले primary alkyl halide, dehydrohalogenation, E2 mechanism. Tertiary, E1. What about the secondary alkyl halide? May occur by E2 or E1. कुन बेला E2 मा हुन्छ कुन बेलामा E1 बाट हुन्छ त. ओके, तपाईलाई कुन कसरी गर्नु छ यदि E2 मेकानिजम छ भन्दाखेरि त्यही अनुसारले गर्न पर्यो. It should be in presence of strong and concentrated and in non-polar. यदि E1 mechanism बाट गर्नु छ भन्दाखेरि it is done in presence of the weak and low concentrated base and in polar solvent. Likewise, the nature of the leaving group, of course, त्यसैले elimination, when you say elimination, all leaving groups favors E1 and E2. Tara, which one is better भन्दाखेरि? But the good leaving group favors E1 because at the first step of E1 reaction mechanism, ionization occurs, so the leaving group leave the substrate carbon. As in the हामीले SN SN2 मा पनि यही conceptलाई develop गरेको थियौं र with the same concept we can see that the factors governing E1 and E2. Now, यति परिसकेपछि now फेरि के आउन सक्छ? Write the difference between E1 and E2. Now, as I have given you the example of the difference between SN1 and SN2 मैले दिएको थिएँ. Slide पनि हेर्यो होला, हेरिसक्यो? Share गरिसके है तिमीलाई? Hello student.
गरिसक्नु भयो म्याम.
Yes. भनिसकेपछि yes, अब everything चाहिने भएन, spoon feeding. Now, you write the difference between E1 and E2 yourself. अब त्यति बेला जाँचमा लेखौँला भनेर बस्यो भन्दाखेरि some points चाहिँ बिर्सिन सक्छ. त्यसैले आजै तपाईको कपीमा start writing the difference between E1 and E2. Unimolecular, bimolecular, first order, second order. Example, that is the dehydrohalogenation of the tertiary alkyl halide, primary alkyl halide. Then how it is formed, that is okay. Then that is in the E1 mechanism, we can see that even the weak and the low concentration base favors E1. Then the opposite is your E2. Polar solvent favors E1, occurs by ionization. Non-polar solvent favors E2 mechanism. Likewise, go on writing the difference between E1 and E2. And this, I think the point of E1, E2 ma SN1, SN2 भन्दाखेरि पनि यसमा अलि कम हुन्छ point किन भन्दाखेरि यसमा geometry, configuration को कुरा आएको छैन. SN1, SN2 मा के थियो? In the case of SN1 मा के थियो? The product is formed with retention of configuration and inversion of configuration, whereas in SN2 मा के थियो भन्दाखेरि it is only formed with the inversion of configuration, but in E1 and E2 mechanism you don't need to describe the configuration भन्दाखेरि अझ त्यो point चाहिँ नि कम हुन जान्छ. So please start writing the difference between E1 and E2 है. र अब हुन त क्वेशन प्याटर्न क्वेशन ब्याङ्क तपाईले पछि चाहिँ पाउँछ होला. Just what does SN1 SN2 represent? 1 marks. Explain the SN2 reaction mechanism with a suitable example. भन्दाखेरि suitable example be clear and then start writing. Okay, SN1 with a suitable example. Explain the hydrolysis of the primary alkyl halide. Explain the reaction mechanism of the hydrolysis of primary alkyl halide in aqueous medium. Hydrolysis of primary alkyl in aqueous medium भनेपछि the S1 SN2 E1 E2 कुन हो? चारवटा परेको त याद हुन्छ, कुन हो? Be clear. Mind set गरिसकेपछि then start writing. है. Why the product of SN2 is obtained with only the inversion of configuration? 1 marks. What are the configuration of the product of SN1 reaction mechanism? If you have understood the SN1, SN2, E1 and E2 in detail, अब जताबाट question घुमाएर लेखे पनि अथवा straightforward question दिए पनि you can attempt, you can do it. र chemistry भनेको it's like a math, you can get a full marks. Full marks भन्दाखेरि म full त भन्दिन, यो 80 marks मा 80 त पाउँदैन, त्यहाँ कता कता language कता के भइरहेको हुन्छ. You can secure 75 even 76 out of 80 for your final. तर assessment मा चाहिँ नि yes 20 marks भयो assessment मा चाहिँ नि के छ भन्दाखेरि you can secure 20 out of 20 in for your assessment. Right? So this is about the SN1, SN2, E1 र E2 यति पढिसकेपछि according to your syllabus के छ भन्दाखेरि 10 marks. या के छ भन्दाखेरि तपाईको final pattern मा reaction mechanism 10 or stereochemistry 10. यदि reaction mechanism मा 10 marks आएको छ भन्दाखेरि stereochemistry मा 5 marks आउँछ. stereochemistry मा 10 marks आएको छ भने reaction mechanism मा 5 marks. तर धेरै जस्तो यदि राम्रोसँग बुझेको क्वेशनर छ, यदि पढाएको छ भन्दा के देखिन्छ भन्दाखेरि excuse me, यो reaction mechanism मा अलिक content बढी छ than in the stereochemistry. त्यसैले धेरै जस्तो reaction mechanism 10 marks दुईटा question and then stereochemistry 5 marks. त्यहाँ तपाईको जुन मोडल पछि देख्नु होला त्यसमा अलिक कन्फ्युज नहोस्. 10 5 or the 5 10 भनेर हुन्छ. त reaction mechanism धेरै छ 10 marks. So if you understood this reaction mechanism in detail about E1 E2 हैन, SN1 SN2, what are the factors governing SN1 SN2 हैन, यदि राम्रोसँग बुझेको छ भने now यो सेमेस्टर मा 10 मार्क्स आइसक्यो तपाईको र जाँच मेरो एसेसमेन्ट मा 5 नम्बर. एसेसमेन्ट मा हामी के गर्थ्यौं भन्दाखेरि 20 मार्क को हुन्छ. 4 जनाले केमिस्ट्री पढाउँदै हुनुहुन्छ होला हैन. अर्गानिक इनअर्गानिक फिजिकल एन्ड इन्भाइरोन्मेन्ट सबैको 5 मार्क्स को आउँछ. फर योर एसेसमेन्ट 20 मार्क्स. सो 5 मार्क्स फ्रम मी. यति पढिसकेपछि न 5 फ्रम मी तपाईले सिक्योर गर्न सक्नुभयो र एसेसमेन्ट फर योर सेमेस्टर 10 मार्क्स. र याद गर्नु होला अर्गानिक केमिस्ट्रीमा बढी मार्क्स छ देन योर इनअर्गानिक एज वेल एज योर अदर फिजिकल और इन्भाइरोन्मेन्ट है कम्पेयर गर्दाखेरि. सो अब सो आई फिनिश द इलिमिनेसन रिएक्सन SN1 SN2 र तपाईको जुन स्लाइड शेयर पनि गरिसकेको छु र त्यसमा हेर्नु होला. यदि त्यहाँ कुनै if you have any queries then we can consult the next class. Next class भनेको अब हाम्रो yes Sunday हुन्छ. That is about म न्यू टपिक मा जान्छु. That is the stereochemistry. Right? With this I can leave the class. Thank you so much for this extra class. Okay, have a nice day, have a good day. Any question? Okay, let's leave. Right? Bye.